Hello all, we are group 6 and this is our video. In short, we have just drawn a block diagram of the parts that we are currently using in our setup. We are using a base station. The base station is where the coordinator sits. There are 5 sensors that are connected to it. We are using a Python programs that runs in a laptop. Since it's a Python program, we are embedding it into the Raspberry Pi as well. So base station part, we have done some intricate changes around the code. Last time around, there were some problems with packet loss, but this time around, we've handled our code in such a way now to prevent that. And further details of what are the change that we have done, we'll be explaining the subsequent sections. So once this is done, we have been in a position to establish the communication. We populate the values that are coming from the base station onto a data store. So once we receive the data from recording all the sensors, we are using data store, which is MongoDB. MongoDB is where we store our data, and this is the schema that we've used. We are populating a timestamp along with the temperature values from each of the sensors. MongoDB is stored in a cloud database. This is something we use because we wanted everyone in the team to be connected. There is no hard and fast tool that we use cloud. We can have Mongo either on the Raspberry Pi or on our local laptop. So once the MongoDB is built, we collect as per the requirement historical and real time. For historical view, we are using a tool called Plotly. The reason we have gone for this tool is none of us were conversant with JavaScript. And Plotly is something where everything can be embedded within Python. So there is no additional software or programming language that we needed to learn. For real time, we are using a tool called PubNub, which is a free subscription based software. PubNub publishes the results of whatever we get from the Mongo into channels. So we have 5 different channels for each of the temperatures. And once PubNub is published, we are using the data what is subscribed by PubNub into real-time charts. For that, we have used the Epoch JavaScript to plot and show the visualization.
So as you can see, the sensors are now returning values to the coordinator. As compared to the last week's challenge, we are now not losing any packets of data because we are using the previous values of the previous read values of the sensors with the assumption that the temperature doesn't change drastically over a short period of time. These readings are now being published to a database using the PyMongo library, and this is the plot. As you can see in this on this page, we are using a software called PubNub, which is publishing the data from the sensors to a channel. This data is being accessed by this HTML file and plotting the real-time data from one of the sensors.
Here, as you can see, we have SSH to the Pi. Now we're gonna demo the database. We are gonna connect to the database and show the content of the database on a Raspberry Pi. Now here I've queried to the database, and when I click enter, it's gonna show all the entries in the database.
This is a demonstration of the visualization of the data collected by our sensors. We have used the plot ly to graphically visualize our data. Here you can see the first graph is the graph of the data collected by all the 5 sensors represented against the timestamp. This data is collected over 9 hours, and below that is the same graph with the average temperature. Uh, and after that, we have shown the average temperature collected over 20 minutes, 10 minutes, and half an hour. Also, data collected by 5 sensors over half an hour.